In this video, we discuss our solution to the VAST 2020 Mini Challenge 1. In order to solve the challenge, we built a series of tools. We will show these tools first before discussing our solutions. We started by using simple NodeLink diagrams to engage in exploratory comparison of the template and candidate graphs. The different shapes of the node indicate the node type. Circles, for example, represent persons, while stars represent travel destinations. The color of a node indicates an assigned location. We filtered edge types using the checkboxes. In order to derive graph structural metrics, we used graphlets, which are structural patterns within a limited number of nodes of a graph. Graphlets allowed us to compare the connectivity structure between the template and the candidates and doing pairwise node matching to find good matches in the big graph. We compared the graphlet frequencies of the persons between the template and the candidate graphs using heat maps and using global graphlet frequencies to see if there are some correlations. In order to analyze activity patterns in the data, we created custom temporal views. This one here shows detailed temporal activity in each graph. Edge types are encoded by color and people sorted by their number of activities. We also created a temporal series view by counting the number of edges with temporal information for each day. This helped us estimate the similarity of candidate graphs and detect a time shift compared to the template graph. This visualization aims at evaluating how good a match is based on similarity measures and the communication channels. The top row of circles are template nodes. The bottom row of circles are matched nodes in a candidate. In between each pair of nodes are 6 rows of similarity. These 6 rows allow to give an overview of the strength of a match. Arcs correspond to communication by email or phone. On the top, the arcs are edges in the template graph. On the bottom, in the matched graph. The arc color indicates the agreement of the two graphs. A green arc is common to both graphs, while a red or gray arc is missing from one graph or the other. Finally, the bottom graph plots the edge colors in relation with the time to ease the identification of matches that perform well only for a certain period of time. Next, we show the answers we arrived at for Mini Challenge 1. Graphlets and custom temporal visualizations allowed us to choose an answer for question 1. Both confirmed that candidate graph 2 had the closest similarity. For question 2, we applied a crawling algorithm to extract subgraphs from the seeding edges. The results can be evaluated using a NodeLink view or the person matching view tool. We can see that the subgraphs found have a lot of common edges with the template. For question 3, we were able to find a perfect match mainly by looking for nodes with a very similar demographics profile or whose travel records, shifted by 14 days, included all the travels of nodes in the template graph. For question 4, we created an extended subgraph from the matched graph we found. We found a communication peak on the 11th and 12th of November. We discovered that there were 7 days without communication, after which 8 people communicated extensively. We suspect that those 8 people, along with 4 more that communicated in the previous 2 days, are responsible for the incident. We faced 2 main challenges. First, the graphlets computation was costly in the big graph, and finding a good distance was not trivial. Second, choosing the best distance or combination of distances was hard, given all the possibilities. This is why we also built a manual matching tool in the end of our analysis process. The manual matching tool is composed of multiple views. It works by allowing to select possible node pairs from a sortable list of similarity measures. Each node pair can be studied in detail before deciding to incorporate it in the final match or drop it. Our visualization tools are available on GitHub.